relation and function. Let me first define the relation and function. Relation, a set of ordered pairs of real numbers. A relation could be one-to-one, one-to-many, many-to-one, and many-to-many correspondence. Relations that are one-to-many and many-to-many are not functions. So next is the function. A function is a rule of correspondence between two non-empty sets such that to each elements of the first set is called the domain. Their correspondence one and only one element of the second, the set called range. Function, a special type of relation in which each member of the domain is paired with exactly one member of the range. These are the examples on how to determine if a relation is also a function. Example number 1. In this correspondence, the students' names are the elements of the domain, and the height of the students are the elements of the range. The students' names are Ives, Reggie, Mehdi, Joy. The height of the students are 120, 123, 130, and 170. So, as we can see in the given, this is an example of a relation which is one-to-one correspondence. So, this is an example of a function. And we determine this is a relation is also a function. So, if you pair this, 5 and 7, 6 and 7, 7 and 10, 8 and 10. So, this is the ordered pairs. So, we can say that the relation of each others are many to one. So, we determine that this is a type of a function. Example number 3. Is the following relation a function? So, let's determine if the following relation is a function. The domains are -1, -2, 0, 1, and 2. The range are -1, -2, 0, 1, and 2. So, the ordered pairs are -1, +1, -2, and +2, 0 and 0, 1 and -1. We can say that the relation is definitely a function if every x value is unique and is associated with only one value of y. We can say that a relation is not a function if we have repetitions or duplicate of x values with different y values, then this relation ceases to be a function. Example of not function. X values or our domain are -3, -1, 0, +5, and +5. Our y values or our range are 7, 5, -2, 9, and 3. So, as we can see, the number 5 are repeating or duplicate. So, we can say that this is not a function. Example of functions. X values or our domain are -3, -1, 0, +5, and +2. And our y values are 7, 5, -2, 9, and 3. As we can see, there are unique x values, so we can say that it is a function. These given are some exercises to determine if it is a function or not function. First one, the given is 1 and 2, 2 and 3, 3 and 4, and 4 and 5. In letter B, 1 and 1, 2 and 2, 3 and 3, 4 and 4. Letter C, 1 and 0, 0 and 1, -1, and 0, 0 and -1. In letter D, -2, +4, -1 and 1, 0 and 0, 1 and 1. In letter E, 1 and +4, 1 and 3, 2 and 5, and 3 and 6.
Go.
Letter C, function because it has no repetition. Letter D, function again because there are no duplicate x values. And in letter E, not function because the number 1 are repeat and the x values are repeating or duplicate. linear equations. In mathematics, a linear equation is an equation that may be put in the form where r, the variables or unknowns, and r coefficients, which are often real numbers but may be parameters, or even any expression that does not contain the unknown. Like this, in this linear equation, the x and y are, the x is 1 and the y is 3. So the our graphings is 1, 2, 3. So this is the point. Then next is the x of 2 and y of 1. Next is this is the 2 and 1. So it intersects with the this point. Next is the 3 and negative 1. So 3 is our x. So this is, and our y is negative 1. It intersects in this point. So the equation is linear. The quadratic formula, or quadratic equation rather, uses the a, b, and c from ax squared plus bx plus c, where a and b and c are just numbers. They are the numerical coefficients of the quadratic equation they've given for you to solve. Y is 0. If we graph this, our range is 0 and our domain is negative 3. So we need to find negative 3. 0 from negative 3, and this is the point. So, and next is the domain, which is 1, and the range is 0. From 1 to 0. So this is the point in number 1. Answer for the y is equals to x squared plus 2x minus 3 is x is equals to 1 and x is equals to negative 3, and our y is 0. In this solution, the negative 3 is our x-intercept and 0 is the y-intercept. And this one is the x-intercept and 0 is the y-intercept. So we put the dot here in 0 from negative 3, and this one for 0 from positive 1. So our graph is the quadratic. This is an example of quadratic equation. The y is equals to x squared plus 2x minus 3. So you need to factor this. So the factor of x squared plus 2x minus 3 is x minus 1 times x plus 3. So 0 is equal to x minus 1 times x plus 3. So our x is equals to 1 and the next x is equals to negative 3.